Hey everybody, today we're going to be talking about two new shapes, the trapezoids and the kites. One thing you want to make sure you remember about trapezoids and kites is that they are not related to the parallelogram. So they have completely separate rules from parallelograms. I know we talked about how rectangles, squares, and rhombus or rhombi were all parallelograms. These are not. So these are going to be separate types of quadrilaterals that kind of have their own categories. You just want to keep that in mind. The first one we're going to start with is the trapezoid. So here's our formal definition. It's a quadrilateral with one pair of parallel sides. Remember, we mark parallel with arrows. So in this particular trapezoid I drew, my parallel sides would be the top and the bottom, and those are called the bases. So there's a base and there's a base. And then the other sides, the non-parallel sides, are called the legs. So here's a leg and there's a leg. And then the angles that are between the base and the leg, so for example here and here, those are called the base angles. So if I ever refer to the base angles, I'm looking at the two that are created by a base and a leg side. All right. When we talk about isosceles trapezoids, that's just a variation of the original trapezoid. In an isosceles trapezoid, we still have parallel sides on one pair, but the legs of the trapezoid are going to be congruent. So it's a trapezoid with legs that are congruent. All right, so one pair of parallel sides, one pair of congruent opposite legs here. The isosceles trapezoid is the trapezoid that has the most rules to it, so that's what we're going to be focusing on in this next slide. We have three main rules that you're going to want to know. The first one is that if it's isosceles, then both pairs of base angles are congruent. So if I mark this as an isosceles trapezoid here, then that means that my angles on the bottom would have to be congruent, and then the angles on the top would have to be congruent. And also one thing to keep in mind is that in trapezoids, since the top and bottom or the bases are parallel, that means our rules about consecutive interior angles can be very useful here as well. So that's something to keep in mind, that not only do we have some congruent angles here, but we also have some angles that are supplementary or consecutive interior, and that could be helpful when finding missing measures. All right, so that's the first rule. Second rule is if you have one pair of congruent base angles, then that means it automatically has to be isosceles. So if I tell you in this one that the top and bottom here are parallel, and then additionally I tell you that I have one pair of angles that are congruent as base angles, then automatically we'd know that's an isosceles triangle. All right, so it's kind of like the rule number one, except I'm giving you less information, and that would be very helpful. And then lastly, it's an isosceles trapezoid if the diagonals are congruent to each other. So that's going to be very helpful. We don't know that they bisect each other, but we do know that they are equal lengths. So we could set up some equations to solve for those missing diagonals if needed. All right, so three big rules. Make sure you write those down. Make sure you know that they have one pair of parallel sides. That's going to be very helpful as well. And then we're just going to go ahead and jump into some examples. The first example I want to go through is if I give you points to graph. This one I have plotted the points already for you, but it says show that it is a trapezoid. So we need to show some calculations, and then determine if the trapezoid is an isosceles trapezoid. Well, before you even get started, you got to know what you need in order to show that something is a trapezoid. Remember from our definition that a trapezoid has one pair of parallel sides. If we look at this, all we need to know if something is parallel is if their slopes are the same. So what we could do is find the slopes of two of the four sides and see if they are parallel, and then we should be good to go. So I'm going to go ahead and find the slopes of GK and of HJ, and if they're equal, then we know that we have some parallel sides. So remember, slope is just rise over run. So we've got from K to G, we go up 1, 2, 3, 4, and then over 2. So up 4 over 2, and it's negative. So that's going to get us negative 2 over 1. And then I'm going to do the same thing from J to H. So I'm going to go up 2 and to the left 1. So up 2 to the left 1, which means it's negative. So these are matching, which means that they are parallel. So we know it's a trapezoid. We have a pair of parallel sides. So I'm going to go ahead and mark those parallel. And then it says, determine if it's an isosceles trapezoid. Well, remember, in order to figure out if something's isosceles, not only does it have to have a pair of parallel sides, but the legs, or the non-parallel sides, have to be congruent. So what we need to figure out is the lengths of segment GH and the lengths of segment KJ. And remember, there are two ways to do that. You can use the distance formula, which some of you guys should know. So that's important. If you don't, make sure you go back and write down that formula so you have it to refer to. Or you can use Pythagorean theorem. The Pythagorean theorem tends to be the quicker option. You just got to make sure that you've got some nice points to work with if you're going to use it. So if I do use the Pythagorean theorem, I'm going to make a right triangle from one point to the other, and I'm going to count those spaces. So I went over 4 and up 3, and I'm going to plug that into my formula. So I'm going to have 4 squared plus 3 squared equals c squared, and I'm looking for my length of kj. So I get 16 plus 9 equals c squared. That's 25 equals c squared. And then if we take the square root of both sides, we get that the value or the length of k to j is 5. So that's the length there. And then I can do the same thing. Let me clear this off a little bit. For the length of g to h. So I'm going to make a triangle going up and then over. It always has to be a right triangle. Keep that in mind. So I went up 1, so 1 squared, plus, and I went over 1, 2, 3, 4, 5. So 5 squared equals c squared. That gets me 1 plus 25 equals c squared, or 26 equals c squared. And I take the square root of that, and I get that length is the square root of 26. And if you want the decimal answer, that's fine, but the square root of 26 is not the same as 5, so these are not equal, which means it is not an isosceles trapezoid. Okay. And that's all you need. So you need to find the slopes of one side, see if they're parallel, and then find the lengths of either the diagonals or the legs, and those will work as well. So that's it for the first example. The second thing I want to talk about is the mid-segment. So this is a new vocab word. Make sure you write this down. The mid-segment is a segment that connects the midpoints of the legs. So these points here, I'll call them H and T, would be the midpoints. And the segment that connects them, H to T, is called the midsegment. And it has this unique relationship between the bases. So the midsegment theorem, which you want to write down as well, basically just says that the midsegment, this length of this segment, is equal to half the sum of the bases. So 1/2 base 1 plus base 2 if you want a formula. So the midsegment equals 1/2 the sum of the two bases. And maybe we call this base 1 and base 2. The easiest way to show this is to jump into an example. Example 2 here. Let's say I wanted to find the length of this midsegment, and I told you that the top base was 10 and the bottom base was 12. Then what I would do is say that x is equal to 1/2 10 plus 12. So add that together, we get half of 22, and half of 22 is 11. So the length of the midsegment is 11. This also could work backwards. Maybe in a separate example, let me scroll down a little bit. I give you a trapezoid, and I want you to find the length of the or I tell you the length of the midsegment. Maybe I tell you that this is 14, and maybe the base here at the bottom is 18, and I want to find the top base. You do the same formula, you just plug the numbers into a different spot. So I know my midsegment is 14, that's what it's equal to, 1/2 the top base plus the bottom base. And then it's just a matter of solving. So to get rid of the 1/2, we multiply both sides by 2/1. So I'm going to do that. That cancels here, so these go away. And I get 28 equals x plus 18. And then all I have to do is subtract 18 to the other side, and I get that my top base was 10 units. We're done. So same formula, just where you plug the numbers in. Just depends on what information you're given. The last example I want to go through with the trapezoids is basic, just dealing with the angles and making sure we know where to find the angle measures. So here I have an isosceles trapezoid. We call it FJHG. And they want you to find these three angle measures. This refers back to the rules from the second slide. Remember that in an isosceles trapezoid, your base angles are congruent. So here, the left side and the right side are the bases because they're the parallel sides. And then FJ and GH are the legs. Easiest thing to do is identify what we have. So we know what angle J is. It's 110 degrees. That means that the base angle that is congruent to it would be angle H. So right away we could say that the measure of angle H is 110 degrees because these two angles are congruent to each other. Next, we have to figure out what angle F and angle G are. Well, we know they are also congruent. That goes back to our first rule. But in order to find it, we have to think about the fact that we have two parallel lines cut by a transversal. That means that angle F and angle J are supplementary. Remember, that means that they add up to 180. Okay? They're also, if we don't just call them supplementary, they are considered consecutive interior, or same side interior, as some of you guys remember it. So angle F and angle J, same side interior, which means they're still supplementary. So we can set up an equation. We could say angle F, the measure of angle F, plus 110 has to equal 180. And then we can subtract 110 from both sides, and we find that the measure of angle F is equal to 70 degrees. So there's the measure of angle F. So if we find that that's 70 degrees, then because we know F and G are the same because they're base angles, that means angle G is 70 degrees. And we're done. So knowing that base angles are congruent is very helpful, as well as knowing that you've got some supplementary angles also makes it a little easier to find your missing measurements. That's it for trapezoids. If you have any questions on how to use the diagonals or how to find any angle measures, let me know. But next is the kites.